This is Mr. Schmidt. He runs a bookstore that sells a specific economics book that every new student of the University of St. Gallen needs. Every summer before semester start, he makes his calculations because he wants to know how many copies he has to order now for the upcoming semester. He estimates the demand based on the past years, but in order to minimize his costs, he needs to take into account the quantity discounts he gets from his usual supplier. To derive the cost-minimizing quantity, he will firstly use the news vendor model to estimate the annual demand that would maximize his revenue. Then he will take into account the discounts he gets for certain quantities. For quantities of 500 to 999, he would get a discount of 3%. For quantities of 1000 to 1699, a discount of 5%. For quantities of 1,700 to 2,399, he would get a discount of 8%, and for all quantities larger than 2,400, he would get a discount of 10%. Based on the discounts, he can then calculate cost scenarios for alternative order quantities.
As said in the introduction, Mr. Schmidt starts by estimating the annual demand thanks to the news vendor model. This model is used to determine the inventory level required to satisfy the demand of the period. In order to do that, he uses costs and values from previous years here. If he orders too much, he can resell the books at a salvage value lower than the initial price, here in the formula. If he doesn't order enough, he fails to capture the whole demand and has negative opportunity costs, here in the formula. This gives, for the different situation, these numbers. Then Mr. Smith can calculate the average profits here based on the different probability here in the table that a specific demand occurs with the formula sum product here. He realized that the optimal order quantity is 120 per period here. Thanks to the news vendor model, he estimates an annual demand of 1,440, which is 120 times 12 months. He has ordering cost of 38 here and holding cost of 5 here. To calculate the total cost for each discount, he uses this table. The number of orders is obtained by dividing the annual demand here by the order quantities here. To calculate the total cost, Mr. Schmidt used the following formula. Ordering cost here plus holding cost here plus unit cost here. The unit costs are changing with regards to discount and to the ordering quantity. From 0 to 499, it's discount 1. From 500 to 999, it's discount 2, and so on. Green shows the lowest total cost here. Mr. Schmidt sees that it's 500. He can also see this in a graph, just here. We can see that the lowest is here. Mr. Schmidt double-checked this result by calculating the economic order quantity in this table here. When it doesn't fall within the discount range, he adjusts it to the closest bound to see the lowest total cost. For example, the economic order quantity is 148 here. The closest value is 500. This year, Mr. Schmidt will target the quantity of 500 books per order to maximize his profit. Another supplier offered another deal. Instead of discounts, he offers free units based on a similar range as for the discounts. For example, for the first interval, there is no reduction. For the second interval, from 500 to 999, there is a reduction of 10 books. For the third interval, from 1000 to 1699, there is a reduction of 75 books. For the calculation, Schmidt used an adapted formula here. He assumes that the supplier sends invoices for a reduced quantity, which result in a minus in the formula, just here. So, the optimal order quantity for suppliers 2 is 1000, this one, laying within the third interval, this interval. Comparing the two offers, Mr. Schmidt sees that he's better off dealing with supplier 1 and his discount model, this one, than with suppliers 2, this one. We can also see this in the graph. For supplier 1, the lowest total costs are here. For supplier 2, it's here. We can see that the total cost of supplier 1 are lower than the total cost of supplier 2, this one. Summing up, Schmidt used the news vendor model to calculate the annual demand. He exported this into the discount model of the supplier in order to calculate the optimal order quantity. So, he found that the optimal order quantity is 500, inducing total cost of 43,263, which remain lower than the supplier 2.